Okay, so this is a little short tutorial to help students of mine understand and get better at doing mole mass, mole particle conversions. Again, we call this the factor label method, which I'm going to show you today. We also known as the dimensional analysis. You may hear me say either one in class, but it's the same thing. So let's see how we do this again. I'm going to go through this slowly. My suggestion is watch the video. If you're still confused, try to watch it with somebody else who maybe then can help you understand it. If that doesn't work, please come in and see me. Okay, so the method we're learning in class is called the factor label method or dimensional analysis. Either one is the correct terminology for this. They're both exactly the same thing, right? Sometimes you'll hear it known as the picket fence technique, which again is the same basic technique that we're using with the factor label method. And here's how it works. When you do the picket fence or the factor label method, all you're doing is you're converting from what you were given to what you want through a series of conversion steps. Now, you can make this only one conversion step, multiple conversion steps. For example, if I want to convert from minutes to seconds, that's only a single conversion step. But let's say I wanted to convert from like years to seconds, right? I'd have to go from years to maybe weeks, to maybe days, to maybe hours, to then maybe minutes, then maybe seconds. So you can multiply 5 times, right? So the number of conversion steps is defined by how many conversions you're going to do to get to your final want. And for our chemistry class, we're going to do no more than 3 conversion steps at all during this year. So the first one we're going to do is just one step at a time. Okay, so when you look at a picket fence, there's a couple of things that you have to realize. Bottom line is it's just a bunch of fractions that are being multiplied each other. Each picket fence section is just a fraction. So it's like 1 over 2. So how do we do this? We're going to multiply everything in the top boxes together. And then we're going to multiply everything in the bottom boxes together. So when we get the end here, we're going to get the top box product divided by the bottom box's product. And that would be your answer. So again, everything gets multiplied on the top together, everything gets multiplied on the bottom together, and then whatever you end up with is divided from the top. The top is divided by the bottom. So that's the process we're going to use, and we'll show you how that works in a minute. So for mole particle and mole gram conversions, we need to have conversion factors for each one. So for the mole gram conversion, 1 mole is equal to a material's molar mass. So if I weigh out the molar mass in grams of a material, I get 1 mole of it. Also, if I weigh out 6.02 times 10 to the 23rd particles of that material, I get 1 mole of it. So if I weigh out a molar mass of material in grams, that molar mass contains 6.02 times 10 to the 23rd particles. So these are the 2 conversion factors that we're going to be using in the next series of slides to go from from moles to grams, grams to moles, particles to moles, and moles to particles. Okay, so here's an example problem involving grams and moles. So we want to convert between the 2 units here. So my first question is, what is the conversion factor that I need to know for this particular problem? Because I'm going from grams to moles. So I need to know the molar mass of something. So I'm going to read my problem here, and it says how many moles are in 42 grams of carbon. So the first thing I have to do is look up what the molar mass is of carbon. And when I do that, I find out that 1 mole of carbon equals 12 grams of carbon. So that's my molar mass of carbon, 12 grams. I get to from my periodic table. And there's my conversion factor right there. 1 mole equals 12 grams of carbon. Okay, so now that we have our conversion factor, our next assignment is to determine what are we given in our problem and what are we trying to find. So the first thing we know is we are given 42 grams of carbon. And what we want to find? Well, we want to find how many moles of that. So we're going to set up our picket fence, and we only need 2 sections to our fence today because we're only doing one conversion. We're going from grams to moles. So we write in what we are given in this box, and I'm going to write 42 grams of carbon. Now we put that over 1 like we always do, and then the next thing we want to do is, what are we trying to find? And we are trying to find moles, so we're going to write that here. Remember, it's moles of carbon. And then what are we given again, and what's the unit we're given, or what are we trying to get rid of? And that would be grams of carbon. Okay. And now the last step before we do any math is to put in the correct numbers with the correct units in our conversion factor. Now we go back to our conversion factor and we look at it and we say, what is the number associated with each word in the conversion factor? So here, 1 mole of carbon equals 12 grams. So I need to write whatever the word, wherever the word mole is, I'm going to write the number that's with it, and that's 1. So here, we're going to write the number 1. Now, for grams, we have, here we have 12. So the grams here of carbon, the number associated with that part of the conversion factor is 12, so we put that right here. All right. Now, it's just a math problem now. So remember, we multiply everything on the top, we multiply everything on the bottom, and at the end of the day, the top gets divided by the bottom. So we have 42 times 1, so we're going to say that that's 42 moles of carbon. Now, why do we say moles? Because what happens here is the grams of carbon will cancel out and we have moles of carbon left over. So now it's 1 times 12 on the bottom, and so we put 12 here. There's no unit because we just got rid of it down here. And at the end of the day, when we do all the math, we should get 3.5 moles of carbon. No, I said MOLS here and MOLES here. They're the same thing. I'm just running out of room. You will see moles written MOLS and MOLES. They're the exact same thing. Okay? So that's my final answer. And does it make sense? So let's look at it real quick. If I have 42 grams of carbon and each mole weighs 12 grams, I should have, if I have 3 moles of this, it would weigh 36 grams. If I had 4 moles, it would weigh 48 grams. So I have somewhere in between, so that number makes sense. If I multiplied 12 by 42, I'd have a lot more larger number, and that wouldn't make sense. Okay, so here's our second example, and this time we're trying to convert from moles to atoms and atoms to moles. So unlike the grams to moles, moles to grams, we need a different conversion factor, and I've supplied you with that conversion factor right down here. And there it is. 1 mole is 6.02 times 10 to the 23rd atoms, all right? So now we're going to basically do exactly what we have done before. We're going to circle what we know or what we are given, and here's that. And then we're going to underline what we want to go to, and here's that. Now it's a simple set it up correctly using the picket fence method, do the math, and we should be all set. So we have to draw our picket fence. So let's do that right here. And we have to write in all our things. So what am I given? That goes here, and that's 6.02 times 10 to the 24 atoms. And then again, we always put that over 1. And now what are we trying to find? Well, we're trying to find moles of copper. And what are we trying to get rid of? We're trying to get rid of atoms, right? We're trying to bury atoms, or that is what we're trying to convert from. Now we go down to our conversion factor, and I look for the number that's associated with the word mole, and that's a 1. So we just write the word, or excuse me, the number 1 here. All right, you make that a 1. And then how many atoms? And we know that that's 6.02 times 10 to the 23rd atoms. Now it's just a straight math problem. Remember, we just multiply the top and then we multiply the bottom together like we did, and then we'll get an answer. We put that over here, and we'll do that here. And when I do that, my final answer should be 6.02 times 1 is 6.02 times 10 to the 24 atoms. Excuse me, moles. I'm sorry, moles. I gotta write that moles because that's not correct. And why is it moles? Because that's the unit that I'm left with after I do the cancellation. Remember, because the atoms here will cancel with the atoms here. And then the last thing we do is it's 1 times 6.02, and so we do that, and so we're going to write that here, and that's just 6.02 times 10 to the 23rd. All right, and again, there's no unit on the bottom, and when we're done, when we do the math correctly, 6.02 times 10 to the 24th divided by 6.02 times 10 to the 23rd, the final answer, if you do the math correctly, is 10 moles of copper. And that's that. So it's not really that much more difficult using the different units. You just got to make sure that you put all the numbers in the correct slot, and everything should work out when you do the math. And again, let's see if this makes sense. We have 6.02 times 10 to the 24th atoms, right? That's more than 6.02 times 10 to the 23rd atoms. Okay, so we know that, but it's not much more bigger because it's 23rd to 24th. So we're going to guesstimate it's going to be something a little bit bigger than 1 mole, but not hugely big. So if you get a number that's like, say, 12 times 10 to the 47th, or to the 48th, that's enormously huge compared to 10 to the 23rd. So that means you made a calculator error.